All right, well, we're ready to move on to team three in our challenge stream. They're called interdisciplinary. They're out of Hamilton, Canada, and we've got Isabella and Rabia here to present. Over to you.
On behalf of Team Interdisciplinary, I would like to say good morning and thank you for having us. We are thrilled to be presenting our Challenge for Climate Action solution today.
In 2017, the city of Hamilton experienced its most devastating flood yet, filling the backyards and basements of residents with sewage, and repairs cost the city over $2.5 million. The flooding is a result of rising water levels and increasing average rainfall, both of which are expected to worsen due to climate change. So our team has chosen to tackle problem statement number 8, cities, and will be focusing our presentation on mitigating flooding in Hamilton, Ontario.
Hamilton has been experiencing an average 3% increase in rainfall per year since the 1970s. This increase has negative impacts on the entire city, but especially the downtown core, which has a high density of large impermeable surfaces, specifically parking lots. Flooding is a threat to the aging infrastructure of the city, and it places an unmanageable amount of stress on Hamilton's stormwater system, resulting in doubled costs in the last 10 years. These increasingly frequent storm events result in runoff entering surrounding bodies of water, including Hamilton Harbor. Currently, Hamilton's flood mitigation strategy focuses on improving existing stormwater infrastructure and informing individual residents of flood management strategies. However, these measures ignore the urgent need to increase Hamilton's capacity to absorb, filter, and divert water from storm sewers during high rainfall events. Also, they do not acknowledge that the high density of impermeable surfaces in the city's core are a main contributor to flooding.
To adapt to and mitigate the effects of climate change, we propose that Hamilton adopt a 3-tier classification system for parking lots and use this system to incorporate permeable surfaces as a flood mitigation strategy. Permeable pavement is a porous surface with an underlying stone reservoir. It catches rain and surface runoff and stores it in the reservoir, allowing it to be filtered as it enters into the ground. There are 2 types of pavement that we would like to implement in Hamilton. The first, which you see on your screen here, is interlocking concrete block pavement, designed with gaps filled with gravel that allow stormwater to infiltrate into the reservoir. The second type of pavement features permeable concrete pavers with grass-based interlocking. The grass-filled gaps can filter out pollutants and allow clean water to return to the earth. And our last strategy involves depaving unused parking lots entirely and converting them into green spaces, which will improve air quality. With these types of strategies in mind, we propose a 3-tier system of incorporating permeable surfaces into the city. The system sorts city parking lots into 3 color-coded categories: red, yellow, and green. Red parking lots are characterized by high traffic. They will be transformed with permeable concrete pavers and gravel interlocking, which can divert up to 45% of surface runoff water away from sewer systems. Yellow parking lots receive low traffic. These parking lots will feature permeable concrete pavers with grass interlocking and divert 85% of surface runoff water. And lastly, green parking lots are unused spaces, which will be completely transformed into green space. Over time, we hope that Hamilton will become less reliant on cars, and that when this happens, parking lots that begin in the red stage will be able to transition to yellow and then green. We strongly believe that this realistic phased-in approach will increase permeable surfaces now, with a long-term goal of reducing the risk of flooding and increasing green space throughout the city.
Permeable pavements will mitigate Hamilton's flooding potential and reduce urban runoff by absorbing more water into the ground and effectively diverting stormwater from sewer systems. Our solution also filters contaminants out from stormwater, lessens the risk of damage to downstream infrastructure, and reduces stream erosion. Permeable pavements also enable evaporative cooling by absorbing less heat, which helps reduce the urban heat island effect, a term used to describe the warmth of the atmosphere and surfaces in urban areas. In the winter season, permeable pavements are also beneficial as they can reduce the use of salt by 75% and therefore lower the cost of winter road maintenance.
In a Hamilton case study, we can see that with transforming the 16 municipal parking lots in the downtown core, our solution could divert up to 16,701,694 liters of stormwater per rainfall event away from the sewer system, and this would significantly decrease flooding risk. Recall that Hamilton spent at least $2.5 million on recovery from a single flood event in 2017. If we consider additional water diversion and absorption from permeable pavement in Hamilton, the financial burden caused by flooding events will greatly decrease. If implemented on a wider scale, our three-tier system of graduating parking lots would have significant long-term benefits. Additionally, permeable pavements work well in tandem with other sustainability initiatives. For example, reducing reliance on cars and bolstering public transportation across Hamilton.
There are several stakeholders that must be consulted and included in the implementation process. Our current implementation plan includes the following steps. 1. The city will connect with local stakeholders, including Hamilton residents and downtown business owners. Also, they will work with environmental NGOs and charities to disseminate information through social media to Hamilton citizens about the process of transitioning to permeable pavement. 2. Determine which municipal parking lots are red, yellow, and green based on high, medium, and low usage through observation and analysis. 3. Sign a contract with a local company that provides deep paving and permeable pavement services to oversee the transformation process. 4. Mandate permeable pavements at least red tier for all municipal owned parking lots. 5. Introduce financial subsidy programs for privately owned parking lots. 6. Expand the program to the entire downtown core and eventually to all of Hamilton. And finally, 7, as the city continues to develop other sustainable practices, moving away from a car-dominant culture, red zone parking lots will shift to the yellow and subsequently green categories. Considering the 16 municipal parking lots in the downtown area, we estimate the cost to convert these areas to the red tier permeable paving to be $5.2 million. The cost of permeable materials will be offset by the long-term elimination of other stormwater infrastructure and absence of damages due to flooding. Given that permeable pavements have been successfully implemented in cities such as Chicago, which also has a combined sewer system like Hamilton, our solution is a feasible method of flood mitigation. Currently, the city of Hamilton spends money on constructing water collection tanks and informing citizens about flood mitigation. However, these are not long-term solutions, and they have not resolved Hamilton's worsening flooding problem.
As climate change causes more frequent extreme weather events and rising water levels in Hamilton Harbor, the need for a long-term solution to flooding in Hamilton is urgent. By adopting our three-tier permeable surfaces system starting in the downtown core, Hamilton will be investing in its own future. Thank you.
Thank you, Isabel. Thank you, Rabia. Pavements have never been this interesting. So I think with that, we can start taking judges' questions. And we've got Judge David Pogue, and he said, excellent work, but permeable pavements cost as much as 3 times as much as standard asphalt. Who will pay? How will you persuade stakeholders to pay that much for a might happen unscheduled problem like flooding?
Thank you for the question. That's a really good one. So the thing is, in Hamilton, flooding is not an unscheduled event. As shown in some of our images in the presentation, this is happening on a regular basis, and the city is not addressing it properly and instead spending money on how to reduce flooding after it's already happened. So our solution addresses it proactively and says, okay, we know that flooding is going to happen, so how can we reduce it from the outset?
And then Judge Mark Broliard asked, how well do these materials deal with snow removal? Also a very strong problem in Canada.
Absolutely.
So as mentioned before, the permeable pavements are able to absorb the water into the ground, and they can reduce salt costs by 75%, which lowers winter maintenance costs. And essentially the way that it works is the water is able to drain into the ground and therefore prevent a layer of ice from forming at the top. So it can greatly contribute to reducing any type of winter maintenance costs associated with roads and parking lots and driveways as well.
Okay. And Judge Janice asks, does winter freeze have any impact like increased cost of maintenance?
The likelihood is potentially, but we couldn't find a lot of research on this just because permeable pavements haven't been implemented in cities as wide as we're asking and proposing for it to be. So likelihood is that there is some potential impact on increased costs for maintenance. But however, as Rabia mentioned before, considering that there's a decreased need for road salt and other types of maintenance, perhaps these costs wouldn't be too much.
Okay. And one last question. How significant is the impact of the solution compared to other ones? You mentioned the lighters, but will this be enough to solve the problem?
So one particular impact of permeable pavements that we think is quite significant is a long-term impact, and that's the fact that permeable pavements enable evaporative cooling, and that helps prevent temperatures from rising in a city. Conventional asphalt pavements produce high surface temperatures that contribute to the urban heat island effect. So permeable pavements can help mitigate that effect and its negative impacts by absorbing less heat. So for example, the evaporative cooling feature of our strategy over the long term will help improve human health and comfort and help prevent rapid pavement deterioration, such as cracks in concrete that can occur due to high heat.
I think we have time for one last question, if you ladies can keep a concise response. It's from Judge Ajay Patel. Did your research find why permeable solutions have not been implemented elsewhere other than Chicago?
Yeah, so there's a lot of places that have done permeable pavements on like a smaller scale, for instance, in alleyways, and not on the scale that we are talking about in terms of citywide parking lots. The reason for that being likelihood is that you have to depave existing pavement. So cities with already existing parking lots and this and the like would have to remove that and then add permeable pavement as well. So likelihood is they're seeing it as an upfront cost and not a benefit in the long-term solution. However, we would like to propose that the long-term solution is a lot better, especially in terms of flood mitigation, evaporative cooling, and all of the other benefits that permeable pavement adds. Rabia, did you want to add anything to that?
No, I think you covered it. The one thing I will say is that the Chicago example has really kind of helped frame our presentation as well. There's a ballpark in Chicago that has over 527,000 interlocking permeable pavement blocks, and it's the largest permeable pavement surface in the nation, and it can absorb 920 gallons of water per minute. Also, that 3.5 million project would have cost an additional $400,000 if it was completed with conventional asphalt.
Ladies, thank you very much for this presentation and good luck.